So if I'm, again, they're giving me two variables to solve for. And my guess is that that means we're going to end up with two equations and two unknowns. Okay. So first of all, but maybe not. In fact, this first one, 16, if that mid-segment connects the two sides of the triangle, what's the first equation you can come up with for 16?
That 4y plus 2 equals that's 71.
I have no idea. I don't recognize it as anything but a 7.
All right.
Although that's kind of weird that it would be 71.
Yeah.
But it doesn't really matter. In other words, once we figure out the technique, then that's all we need. Okay? So what would the next, in other words, here we can solve for y. We have one equation and one unknown.
Okay.
What would the next step be?
For that equation?
Yeah, solve that. Mm-hmm.
Put all the variables on one side.
Give me the next line.
Four y plus, well, so actually 13 equals.
When you see an equation like this, what should be going through your mind is I'm going to put all the variables on one side and I'm going to put all the numbers on the other. So the first question is, which side are we going to put the variables on?
The left.
Actually, if we put them on the left, it'll have a negative coefficient. If we put them on the right, it'll have a positive coefficient. And if I put the variables on the right, I've got to put the numbers on the left. And now both of them have positive coefficients. Positive coefficients or positive numbers are always better than negative numbers. Negative numbers cause people to make mistakes. Had I done it the other way, I would have had minus 67y equals minus 13. Well, that's the same thing, but I'm looking at two negative signs.
All right.
Okay, so just when you have to face that decision as to which side to put your variables on and which side to put your numbers on, because you're going to see 1,000 equations that make you make that decision at some point. I'm just going to advise you, put your variables on the side where their coefficient will remain positive. Always start with that as a starting place.
Okay.
So y would be 13 over 67, assuming that 71 is the right number here.
All right.
What other equation can you write?
Well, we know that the middle line.
Mid-segment.
Oh wait, that.
Mid-segment
I thought
equal to what?
What?
The mid-segment is equal to what?
To like half of the bottom.
The base. And that's how you write that. The mid-segment is equal to half of the base. Or I could have written the base is equal to twice the mid-segment. Both of them are going to give us the same answer. And then I can distribute that. Since everything works out nicely, I'll distribute it. Now, which side am I going to put the variables on?
The left. No, right.
which means I put the numbers on the left, everything stays positive.
The x equals 3.
All right, let's look at 17. Give me at least one equation.
It's 7 equals half of 5y minus 3y.
I think that's 5x minus 3y. Next to positive. Okay, now here we can't solve it because we have two variables and one equation. But now give me an equation that relates those two together.
3x minus 2y equals 8.
Now there's my system of two equations, two unknowns I'm going to be able to solve. On 16, we didn't have to do it. In other words, we got two different equations of one variable only. We were able to solve for x and y separately. But this one, you can't solve for x and y with just one equation. So you have to use both equations. Now, let's talk about solving that. It's a little tricky to solve.
Take away the 1/2 and just make the other side 14.
Okay, that's a good first step. 14 equals 5x minus 3y. Now notice I don't have it exactly in standard format, but close enough. I have the x and the y on one side, the number on the other. Now if I rate the second equation, I get that. Now this isn't the easiest set of simultaneous equations to solve. How do I solve these?
No. You can multiply.
First of all, let's number them because I'm going to have multiple ones. That's equation 1, that's equation 2. I want to do it by elimination because they're in close enough to standard format that elimination is going to work nicely. The problem is I can't eliminate anything yet. So what do I have to do?
We can multiply one of the problems by 5 and the other problem by 3.
Okay, but we make it simpler and choose the y variable, in which case we'd have to multiply one by 2 and the other by 3. And the only reason I like that better is because it's smaller numbers. Multiplying by 5 results in larger numbers. Multiplying by 3 or 2 results in smaller numbers.
Okay.
So let's take the top one. What are we going to multiply it by?
2.
Okay, so that gives us 28 equals 10x minus 6y. Now, number 2, what's the best thing to multiply it by?
3.
If I multiply it by 3, then I'm going to have minus 6y, and I'm going to have to do a subtraction problem involving all kinds of negative numbers. So how about we multiply it by negative 3?
Okay.
Here's what happens when I multiply both sides by negative 3. Is that turns into plus 6y. And now I can add these two equations. I don't have to subtract them. And it's always better when you can add. It's just people do not make the mistakes they make when they subtract. I would say that the mistake rate is like 90% when people are subtracting. When they're adding, it's like 10%. So it's a huge difference. I don't know if it is for you personally, because we haven't worked that much with the differences, but try to, if you have a choice, try to eliminate subtraction and negative signs. Try to make everything an addition problem or positive signs.
Okay.
I got this to a point where if I add those two equations, I get a variable to go away. So let's do it. In fact, it works out perfect when I add them. What do I get?
You get x equals 4.
Start on the left. As long as I wrote it left to right, then let's solve it left to right.
Okay, 4 equals 1x.
That's it. Just solve for x. Now how do you solve for y?
You plug it in.
Which one? I got three choices. I could plug it into that one, or that one.
The smallest one, so number 2?
Yeah, number 2. So I get 8 equals 3 times 4 minus 2y. Again, I'm going to take the 2y on the other side and bring the 8 over, and I get 2y equals 4, y equals 2. So my solutions are x equal 4, y equal 2. And if we plug those in and checked, we should be correct. If I do just that, let's see, I get 12 minus 4, that's equal to 8. That's 8. That's all I need. That convinces me I'm right.
Okay.
In other words, you don't always have to check every single thing. If you do one check and it works, you're most likely correct.
Okay.
All right, number 30. We went from 17 to 30, is that right?
Yeah, it is.
Okay, no problem. So DC is 6. AB is 16. Find ME, FN, and EF.
Would ME, oh wait. Okay, so 6 plus 16 equals 22, so the medium, so MN is 11. And then ME is 3, FN is 3, and EF is 5.
Okay, you know that ME has to be equal to MF.
No, it has to be equal to FN.
I mean FN, yeah. Well, why'd you break it up into 3, 5? What'd you break it up into? You know it's 11, so you broke it up into 3, 5, and 3. How come you didn't break it up into 2, 7, and 2?
Oh, I don't know.
I think you did it correctly, but let me think about this for a second. The only thing we know for sure is that that thing is 11. MN is 11. And we know most likely, yeah, we know that MN is 11. What else do we know for sure? They didn't call this an isosceles trapezoid. So I'm not even sure we know that AC is equal to DB. In other words, if I have a trapezoid that's not an isosceles trapezoid, something like this, then the diagonals are not equal. And furthermore, they don't bisect one another. So there's not a lot you can say about the diagonals. And they do not say that this is isosceles. If it was an isosceles trapezoid, then we would know that those diagonals are equal to one
another. I don't know then.
I'm not sure I know either. I know that MN is 11. Now if we look at this trapezoid, does that help? I'm not sure. I still can't tell whether EF is 5 or is EF 6 or 7, or in other words, nowhere does it say here that everything has to be an integer. What if I were to draw? I'm beginning to think this is a typo. In other words, I think they meant to call it an isosceles trapezoid. And here's why. If I draw this trapezoid and I don't make it isosceles, in fact, kind of the way they've drawn it, it's not isosceles. You know what isosceles means, that these two side segments would be the same. Well, if I don't draw it isosceles and I still put a median through there, well, we know the median is half the top base and the bottom base. But if I draw that line and that line, that distance is not the same as that distance. At least I don't think it is. If I really draw it weird, and I draw it like this, I draw the median, now I draw that and that, well, then it's clear that that's not the same as that, right?
Right.
In fact, if I draw it with this picture, I would not be able to tell you what those three line segments are. I could tell you what the entire mid-segment was, but I would not be able to tell you what the individual line segments are, because depending on how I draw that trapezoid, they change. In other words, in this picture here, that middle section, I suppose, could be 5, but it would change the distance of ME and FN. So I'm not sure how I can answer this question. I honestly don't believe they've given you enough information. I mean, if you put a gun to my head and said, answer it, then I would give your answer. 3, 5, and 3. At least that adds up to 11.
Yeah.
That's only going to be true if that is an isosceles trapezoid. In other words, if DA is equal to CB, and they haven't even drawn it that way, let alone say it that way. So I'm not sure about this problem here. And it's going to infect every other question here also, because I'm sure that all of them, well, let's see. Let's take a look at the next question. Now, again, question 31 does not assume that question 30, right?
Right.
Okay, so I have to start from scratch. Prove that EF, well, maybe this is going to tell us, is equal to half of AB minus DC. Ah, okay. And that would tell us that it's 5. So if that is true, now I can go back to that problem, and I do know that EF is 5. Still not sure that that makes ME and FN both 3. Let's see if we can figure out how to prove this. EF is half the difference. Wow. Because we know that MN is half the sum. So it's half the difference. Wow.
The EF is half of
The difference of the top base and the bottom base. In other words, we know that if 30 is true, then EF would be 5, just like you proposed it would be. But
Okay.
this is saying that it's half of those differences regardless of what the numbers are, and regardless of whether it's isosceles or not. I guess. I'm still not convinced that they didn't mean to say this is an isosceles trapezoid. So we're trying to prove that that is half the difference between the upper base and the top base. Wow. How are we going to do that? Ah. Okay. If you look at that triangle, you know, that's not a mid-segment. In other words, if I were to draw this figure right here and try to figure EF based on that figure, can't get anywhere. How else would we prove that it was half? Well, what if we look at it like this?
Oh.
Does that help? In other words, MN is definitely half of AB plus DC. So why would EF be half of AB minus DC? That's what they're saying, is EF equals half of AB minus DC. Well, let's do a little algebra. We got 2MN equals AB plus DC. And we got 2EF equals AB minus DC. If I add those two equations together, I get rid of the DC, and I get 2MN plus 2EF equals 2AB. Which tells you that EF is equal to MN minus Geometry is one of those things where when you run into a problem and you can't figure it out, sometimes I find myself staring at these pictures for like 15 minutes. That's all. I don't write equations. I just stare at the picture for 15 minutes. And the answer will come to me. And that may be what I have to do here. In other words, I could imagine that that's probably a true statement, even if I have a weird-looking trapezoid. If I have a trapezoid like this, it would not surprise me if EF was half of the difference between the base and the bases. I'm just not sure how to prove it. Let's have a look at 32, and your test is tomorrow, right?
That is true.
Too bad we didn't cover this problem yesterday. I would have had some time to think about it. If I do figure out how to prove 31, maybe I'll try to text you later or something. I don't know. I'm busy until 9 tonight, so it's going to be hard for me to get back to you. What did you just say? I'm sorry.
I can look at the answer real quick.
Oh, okay. Yeah. Let's do that.
I don't put it there though, but I'll see. Oh, we have to do proof.
Right. It's a 2-column proof?
Yeah. There is no answer there.
Oh, okay. So they don't give you an answer at all?
Nope.
All right. Let me think about that one. Maybe I can come to some conclusion on it. I'd hate to think that all 3 of these problems are dependent on this being an isosceles trapezoid that they just happen to forget to mention.
They might have done that.
They could have definitely done it.
Yeah, because the answer for the 30 is 3, 3, and 5. I was right.
Right. And that would make it an isosceles trapezoid. I don't think you get ME equal to FN unless it's an isosceles trapezoid.
Yeah, I think it's just
here. I can draw it.
I think it's just given that it's an isosceles triangle or trapezoid, because that's the only one we've worked with.
Well, the problem is that's a horrendous mistake on their part. It really is. It's a horrible mistake, especially with geometry problems, because you can spend 20 minutes trying to solve this, and it's all because somebody screwed up on their end and didn't list the conditions properly. Okay. Right. But here, I just drew a trapezoid, and there's no way that that distance is equal to that distance.
No, that's true.
So it has to be an isosceles trapezoid for ME to be equal to FN. And that's probably the only way to prove that EF is half of the difference of the bases, is by assuming that it's an isosceles trapezoid also. Now here, and this is going to assume the same thing. So find the value of x. Well, if the previous statement is true, then we can say that 7 equals 1/2 of 2x squared minus 3x, correct?
Correct.
That turns into a quadratic. You get 14 equals 2x squared minus 3x. Subtract 14 from both sides, you get 0. Factor that.
What would be?
Split the x's up first.
Yeah, so it would be x. Yeah, it'd be, well.
It's the only choice.
Can you put the x on the other side too?
Yes, you can put them in either order, but it's got to be 2x and x. Okay. It can't be 2x squared and 1. In other words, we know that these two have to multiply together to give you 2x squared. Okay? And in terms of producing the middle term, I'm going to guess minus 7 goes there, plus 2 goes there. That produces minus 3x. So that's correct.
Doesn't that produce minus 5?
No. If I do the insides, that's minus 7x, and the outsides are plus 4x. That's minus 3x. In other words, whenever you're factoring a quadratic, what you want to check is the middle term. I know the first term is correct, and I know the 14 is correct. The term that's always in doubt is that middle term. So you got to check that middle term. And with minus 7 and plus 2 produces the correct middle term. Therefore, that's correct. Therefore, x is equal to either 7/2 or minus 2. Which one is the answer?
7/2?
Has to be a positive number.
Oh, it
Because
does?
they've told us that DC is 3x. So x cannot be a negative number. So that's an extraneous solution. We go with our positive answer, and this would make everything work. Assuming that's an isosceles trapezoid. Even if I assume it's an isosceles trapezoid, well, yeah, because that changes everything. That makes that line the same as that line and lets you do all kinds of things. So you definitely need to know this is an isosceles trapezoid to do that problem. And whoever put this problem on there, if that really is true, should be shot. There's no excuse for putting typos on math problems and then telling people to go out and spend an hour doing the problem.
Yeah. Okay.
I mean, that's almost unforgivable. There's some typos that you can understand, but not that one. All right, and I could be totally wrong, but I don't think so, because I don't know how you can answer question number 1, which was what, 16?
Yeah.
I don't know how you can answer question number 16 if it's not isosceles, because the relationship between those two end segments is different. They're not equal. It's not 3, 5, 3.
Okay.
All right, let's see. Angle 1. All right. So that's nothing special that we're looking at. Angle 1 is greater than angle B. True or false? If you look at that triangle and this triangle alone, what's the theorem about angle 1? Two angles is it equal to?
Equal to
It's equal to B plus A.
B.
Yeah. In other words, whatever that angle is and that angle, they add to angle 1. There's an exterior angle theorem for triangles. In other words, if I draw any triangle, this angle, A, is equal to B plus C. It's equal to the two angles that are not a linear pair with it. In other words, you eliminate that one, and it's equal to the sum of the other two. So if it's equal to the sum of A plus B, then it has to be greater than B, right?
Right.
So we can definitely prove that. Okay. this angle is less than DAB. Wow. Why is that?
Why?
Yeah. In other words, it's obvious from looking at it.
Yeah.
But what actually they don't require you to give the reason.
Nope. It's just a yes or no.
Clearly it is. And the reason it is because the angle segment theory. In other words, an angle is made up of its two segments. That's one of them. That's another one. Therefore, any of those segments is less than the entire angle.
Okay.
But once again, they didn't really ask us to prove it. They just want a yes or no here. BD is greater than CD. Well, what are we missing here? Why is this question on here? Given C on line BD and angle 1 is an exterior angle, tell whether the statement can be deduced. Right? Yes or no?
Wait, angle 1 is like angle. Which one's angle 1?
Right there.
Down. Oh shoot, I saw that.
But BD is greater than CD because of the line segment theory.
Yeah.
Right?
Right.
In other words, you have an angle segment theorem and you have a line segment theorem. And that's a line segment. BD is on the same line as CD and it's bigger. So I don't know. Yeah, if all they want is a yes or no, then we got that. Hold on a second. We were to redraw this so that that is AD. It would still not be the same as AB, right?
Right.
Now, I can't really say that BD is greater than CD. Well, I could, but I could draw it even weirder still. In other words, what if I draw it like this? That's still a different length than AB. That's not now my angle 1. And I wouldn't be able to say that BD is greater than CD. It wouldn't be in this case. So, and yet 1 is still an exterior angle. C is still, given C on BD. So this picture doesn't work. C has to be on the line BD. So this really is the only picture that we can deal with. And in this picture, hold on. I apologize. No, BD has to be greater than CD by the line segment theory. Since CD is a part of BD. All right, 22. Angle DAC, again, this angle here, is less than CAB. True or false?
That is false? Or no?
Cannot be deduced. And in other words, the way they've drawn it here, yes. But you don't have to draw it this way. What if I draw it this way? In other words, nothing in the world says that it has to be the way they drew it.
Okay.
Still have an exterior angle. Still have that is not the same as that.
Mm-hmm.
And this angle here looks to be bigger than that angle. I could certainly draw it that way if I wanted.
Yeah.
So if there's two ways you can draw it, and neither way conflicts with the original statement, then no, I can't tell the DAC is less than CAB. On the picture, the way they've drawn it, I can tell it. But
kind of look.
now, no, I keep misreading 21. I keep wanting to read 21 as BC is greater than CD. It's BD, and BD is always greater than CD, even when I draw it this an exaggerated way.
Yeah.
So we got a yes, a yes, a yes, and a no on those four.
Okay.
And I'm sure about 19. I'm also sure about 20 and 21, and 95% sure about 22. Because I'm assuming we can draw this picture any way we want as long as it conforms to their conditions here. In other words, C has to be on the line BD, and that left side has to be different length than the right side, and angle 1 has to be an exterior angle. All right. So we got to get through these three problems, and you're good to go, huh?
Well, I still need to do the ones we skipped.
Right. Which one takes priority? Should we do these three?
Yeah.
These are going to be fairly easy here. Tell me how I'm going to solve 28.
Well, know that.
Got to find the biggest angle, because unless you find the biggest angle, you're not going to know which is the biggest side. The biggest side is always opposite the biggest angle.
Biggest side.
The biggest side is always opposite the biggest angle. In other words, in 29, angle 3 is the biggest angle.
Okay.
Okay? So we got to figure out what these angles are. So give me an equation that allows me to solve for x.
60 equals x minus 4?
No, we don't know that that's isosceles.
Well, 60 plus x minus 4 equals 180.
Okay, that's different entirely. That gives you 2x equals 56, 124. X equals 62. It makes that 62, makes that 58. Now we know that's the biggest angle. HI is the longest. That L or I?
I think it's an I.
Just write it exactly the way they wrote it, and then they can't misread it.
Right.
Okay? So, we had to solve for x to determine which was the biggest angle. Because we couldn't tell. We knew x was bigger than x minus 4, but we didn't know if x was bigger than 60. So, on the largest angle in 29 again?
3.
And the largest angle on 30.
Would that be 1? Oh.
If the choice is between 1 and 2,
Then it is 1 because 8 is large.
Yes, and here's the reason why. If we draw this as a parallelogram, which is the way they drew it, which would mean that would be 7, that would be 7, that would be 12, that would be 12, and angle 1 would be equal to angle 2, right?
Right.
Well, this is almost a parallelogram. The only difference is this left side is 8. Well, in order to get it up to 8, I got to take it up to there and redraw. It's not really a parallelogram, but clearly angle 1 just got bigger.
Yeah.
So when that becomes 8, you're right. Angle 1 is what becomes bigger than angle 2.
Okay.
Again, it's a bit of a typo because neither one of them are as big as that angle.
That is true. Because the one in the middle is the longest.
Yeah, I mean, they didn't specify between 1 and 2, which is the longest or largest angle. All right, let's go back and see what we can find in the others. We went directly to 5, which was that page. Let's have a look at this one. I don't think we've looked at this one. And we only have 10 minutes. Would this be your preference?
What page is that on?
Well, let me have a look. Page 4.
Yeah, we can do that one. I need help on.
We're not going to have time to do the whole page, but
Right.
we can begin it. Corresponding parts and a congruence. So we're going to be using CPCTC here. What can you conclude about angle P? And what this is saying, again with the typos, what am I missing here?
I think it's just look at the given.
Oh, okay. So this first question doesn't have anything to do with these 3 diagrams.
No.
My problem, or my fault. Okay, what can you conclude about angle P? Okay, if I draw 2 triangles and we'll make them congruent.
Could it be that it's congruent to angle 2?
Yeah, in other words, if I label this KOP and label this MAT, then you can conclude that P, the measurement of P is the same as T. Name 3 pairs of corresponding sides. My diagram right there.
Line, or yeah, KP.
Corresponding to what in the other one? That's what they mean by 3 pairs.
Yeah, so
KP and MT, 1 pair.
And then KO and MA and P and AI.
Yeah. Don't know what that question is doing on there either. Not up to Mullen standards.
Yeah.
Okay. Decide whether the 2 triangles must be congruent. If so, write the congruence and name the postulate. If not, write no congruence. Okay, so what we're looking at here is that side is equal to that side. That angle is equal to that angle. Are those 2 congruent?
So it'd be side angle side?
Because that's equal to itself. And so you have side, angle, side. Number 4.
Well, there's vertical angles in there, so I thought it was side or like side angle side.
You're right. In other words, we definitely know that.
Yeah, but like the answer is no. There's no.
Right. The reason is because it's side-side angle. In other words, it's side-side angle. And that's not enough to prove congruency. Now, the question is how could I draw this thing so that they clearly are not congruent, and yet everything is true here? Well, I think I can do that. Maybe. Yeah, what if I draw this line like this and connect it right there? Now, that side is still equal to AC. And CF is still equal to FD.
Oh, I get it.
And that side is still equal to DB. And yet clearly they're not congruent. So just because you have side-side angle doesn't make for congruence. Side-side angle, sometimes there's two different ways you can draw a triangle that has side-side angle. And I just did it. One way would be that way, and the other way would be the way I drew it. That's also the same side-side angle. So you can almost just, if you can't come up with the theorem, then you know it can't be deduced. Okay. And the only thing we can come up with is side-side angle. All right, let's look at number 5. 50, 60, therefore that one's 70. Always fill in the unknown angles. Are those two triangles congruent?
Yeah.
Why?
It's the angle side.
Which side?
The one that they're sharing. Because they share TR.
They do indeed. Yeah, and you can flip that one over TR, and it would exactly lay on top of this one. So they're definitely congruent. The only reason at first I questioned it is because if we take that triangle and we move it to the left, then TR is on top of TP. In other words, they're not really sharing that side. You know what I'm saying?
No.
But that would make it a 50, 70, 60, and that's not what we're looking at. The only way you get a 50, 60, 70 is if you flip it over. In other words, if you kind of reflect it over the line TR. And then TR is the common side, and all your angles match up also. So yes, and it is based on angle side angle. Angle 1 is 20 degrees. It's angle 2.
Is 20 degrees too.
What's angle 3?
That is
Remember the exterior angle theorems, the easiest way to do it. There's two ways to do it. In other words, you can figure out that that's got to be 140 because they have to add to 180.
Oh, that's right.
And then 3 is a linear pair with 140, so 3 has to be 40, but we do it before then. Because angle 3 is an exterior angle, which means it's the sum of angles 1 and 2.
Okay.
So angle 4 equals what? And angle 5 equals what? Well, that's 20. That's 40. That's 20.
Then angle 4 equals 40. That means angle 5.
Right, because it's isosceles, yeah. So that'd be 100. And once you draw that picture, everything else becomes automatic.
Yeah. And then angle 5 is 60.
Or, yeah, whatever that angle. Yes, exactly. In other words, once you get all the angles figured out, then it's got to answer every one of those questions. All right. This, again, is going to be one of those problems where you just fill in everything you know. Okay? That's 23, therefore that has to be 23.
Yep.
Therefore, this angle 3 has to be 134. And since those two lines are parallel, angle 3 and angle 4 have to be supplementary. So angle 4 has to be 46. That's isosceles. Both of those have to be half of 134. So that's 67. That's 67. Now you can figure out angle 7.
90.
Correct. And if angle 1 is K, find 7. We just do exactly the same thing. Let me just get you started here before I hang up. If it's K, well, then that one is K. This one is 180 minus 2K. 4 plus 180 minus 2K. In other words, angle 3 and angle 4 add to 180. So, and angle 3 plus angle 4, that's angle 4. So, let me think for a second here. 180s cancel, and you get angle 4 equals 2K. And so that's 2K, which makes this one 1/2 of 180 minus 2K. So 5 is 90 minus K. And we know that 5, 7, and 2 add to 180. So we got 90 minus K plus angle 7 plus K equals 180. K's cancel. Angle 7 equals 90.
Yeah.
Interesting. Very interesting. That means angle 7 is 90 degrees no matter what K is. Even if K is not 23, K can be any number that's an acute angle, and angle 7 is always going to be 90.
What feels like 89?
Huh? It looks like 89?
What if it was?
It can't be. In other words, the algebra is irrefutable proof. The K's, notice, they disappeared. Okay? So I got angle 7 was equal to 90 regardless of what K is. So I could make K 15 degrees, I could make K 50 degrees. Angle 7 is still going to end up being 90. According to this algebra. doesn't mean K is 23, incidentally. Just because, I mean, this is definitely a Mullen teaser. In other words, we proved that if angle 1 was 23, angle 7 was 90. And then we said that if angle 1 is anything, we'll call it K, angle 7 is still 90. So that tells us not that K is 23, it just tells us that K can be anything at all, and angle 7 is still going to end up being 90.
Okay.
Janessa?
Yeah.
Good luck on your test.
Thank you.
Talk to you. I guess you're done with your quarter, aren't you? So I'm not sure when we'll have our next session. Maybe a week from Thursday. Definitely not this Thursday.
Yeah, definitely not this Thursday.
Okay. Have a good week.
All right. Thank you. Bye.